students, I am Nilanjana Sanyal, an online math tutor from India. Welcome you all to my channel NS Online Math Classes. Now as you know, we are learning the chapter on Binomial Theorem, and now we are learning how to get the coefficient of a term where the power of the variable is given. But now, instead of one single binomial expression, we are having two binomial expressions and they are getting multiplied together. We are in fact having a series of 3 video sessions, and this is part 2 on this topic, that where you will be having two binomial expressions getting multiplied together. This is the part 2 and we have already had part 1. In our part 1, we have seen that we had two binomial expressions getting multiplied together, and one of the binomial expressions was getting raised to the power of 1, while the other was getting raised to some positive number. In our today's session, we will be seeing two binomial expressions that are getting multiplied together and both are getting raised to some positive number power. Then what remains? What will we be knowing in part 3? Let that be a surprise, okay? And stay tuned. This is actually, I would not say a difficult topic, but yes, I have seen many students who get confused. So stay tuned till the end. I hope you will be able to understand the procedure. And if in case you have any question, please feel free to write your question in the comment area. Okay? So without any further delay, let us start with our today's session. So the first question says, find the coefficient of x squared in the expansion of 2 minus x raised to the power of 5 times, there is this implied multiplication sign in between, times 1 plus 2x raised to the power of 6. So let's start with our answer. Both are binomial expansions. These two are getting multiplied. We will be having, how many terms will we be having from this part? Since the power is 5, it will be consisting of 6 terms. And for this, we will be having 7 terms. So, each of the 6 terms from this part will get multiplied with the 7 terms, each of the 7 terms from this part. Okay? So, a total of 6 times 7, that is 42 terms. We will be getting a total of 42 terms. Of course, there will be like terms and we will be adding or subtracting whatever is the sign. Depending on that, we will be adding or subtracting them. But first of all, we will be getting a total of 42 terms. And it is quite obvious that we do not have that time or energy or desire to get all the 42 terms. We just want to get the terms which will be having the power of x as 2. So how to get that? Now, if we take the first binomial expansion, that is 2 minus x raised to the power of 5. X is the second term. So I am taking 2 minus x raised to the power of 5. Since x is the second term, we know that the power of x will just go on increasing in steps of 1. The first term will be having the power of x as 0 and the last term will be having the power of x as 5. Okay? You don't have to write the coefficients of every term. You don't have to write this 2. What you have to write is the powers of x. I am asking you to write all the powers of x because you are new. Afterwards, you don't have to write all of them. You will be knowing which ones to be taken or which ones to be written. Okay. So I have just written the powers of x, 0, 1, 2, 3, 4, 5. And now I am taking this one. 1 plus 2x to the power of 6. Again, x is in the second term, so its power will go on increasing. So again I write the powers of x. Just the powers of x. X to the power of 2, x to the power of 3, x to the power of 4, x to the power of 5, and finally x to the power of 6. Now all these, if I take this will be a constant term. So this will get multiplied with all these 7 terms. Okay. So the constant term does not have any x. So when this constant term, this is another constant term. When these two get multiplied, we cannot expect to get x squared. Definitely we will not be getting x squared from this, the multiplication of these two terms. But when we take the constant term and multiply the constant term, that constant term with this term, it contains x to the power of 1. So the product term will be having x, but its power will be equal to 1. Whereas we need the power of x to be equal to 2. So we come to this third term. We are taking the constant term from the first expansion and we are just checking which term can, when multiplied with this constant term, will be giving us the power of x as 2. Obviously, this constant term when multiplied with this term which contains x to the power of 2 will be giving the product term containing x to the power of 2. Okay. So I take this is the first expansion and this is the second expansion. So I am taking this combination, x to the power of 0, these are the powers of x. X to the power of 0 from the first expansion and x to the power of 2 from the second expansion. Similarly, if I take the constant term from the second expansion and I multiply that constant term of the second expansion with this term, I'll be getting the product term containing x to the power of 2. So the next case will be this is 2 and this is 0. And is there any other way of coming to x to the power of 2? Yes. If we multiply this term which is containing x to the power of 1 with this one which is also containing x to the power of 1, we will be getting the product term containing x to the power of 2. So this is the third way of getting the x to the power of 2 in the product term. And these are the only 3 ways of coming to x to the power of 2. So I would be asking you, if you are confused, you just write all the terms, all the powers of x. Don't have to write the coefficients, don't have to write the first term, just write if the x had this, in this case x is having a coefficient of 1. But in this case, x is having a coefficient of 2 and I did not write this 2. I am only interested in the powers of x. So you just write the powers of x. If x is in the second term, you will be having the powers of x getting raised by 1, increasing from 0. If x is in the first term, you will be seeing the powers of getting decreased by 1 in every term. And I know what question you are having right now. The question may be, what happens if you have x in both the terms? A very good question. That will be the topic of the part 3, where you will be having x in both the terms. Okay. So, in part 1, we had seen that one binomial expression was having the power of 1 and the other was having a power of some positive number. In this session, we are seeing both the binomial expressions are getting raised to some positive number powers. And in part 3, we will be seeing, again we will be having two binomial expressions, and they will be getting raised to some positive number powers, and the binomial expressions will be containing x or the variable in both the terms. That will be the subject or topic of our part 3 session. Okay. So now let us come back to this session. So I would definitely be asking you to just write the powers of x to know which two terms will be getting combined together to give us the desired power of x. Okay. Now that we have got the different combinations, now our next step will be to find the value or values of r. Okay. So we start with the first term. So, not first term, rather first expression. First binomial expression. First binomial expression, that is 2 minus x raised to the power of 5. We will be taking all the three powers of x and we will be getting the values of r for each of them. What do? We start with the general term, right? So we will be starting with the general term. And what is the value of n in our case? It is the power which is 5. So it will be 5cr. The first term is 2. So 2 raised to the power of 5 minus r and x raised to the power of r. Minus x raised to the power of r. So when x is equal to, the power of x is equal to 0, r value will be equal to 0. So r is equal to 0. When x is having a power of 2, r will be equal to 2. And when x is having a power of 1, r is equal to 1. Okay. So these are the three values of r that we have got. You see, I have maintained the sequence. If you just write 0, 1, 2, then it is fine. But in that case, you have to know r equal to 1 is for this third combination. Okay. So it is better that if you maintain the sequence, the possibility of making some mistake will be reduced to some extent at least. Okay. So, because actually maybe you do not make silly mistakes, but most of my students make silly mistakes. That is the one thing that I find that is common to most of my students. They belong to different countries. There are so many differences between them, but the one thing that is common is the tendency of making silly mistakes. I hope you are not of that type, but in case you make few silly mistakes, that's why I would ask you to maintain the sequence. Okay. So I have got the powers of r for the first binomial expression, which is equal to 2 minus x raised to the power of 5. Okay. Now coming to the second binomial expression. So it is second binomial expression. Which is 1 plus 2x to the power of 6. Okay. So, when x is having a power of 2, first of all, we will be starting with the general term, as we do always. So, we start with the general term. It is 6cr. First term is 1, so it is 1 raised to the power of 6 minus 1, rather 6 minus r, and whatever is the power of 1, it will always be equal to 1, and 2x raised to the power of r. So, when x is having a power of 2, r will be equal to 2. When x is having the power of 0, r is equal to 0, and when x is having a power of 1, r is equal to 1. Now, we will be just getting the terms. So, this is the first, or let me write 2 minus x to the power of 5. When r is equal to 0. What is the term? 5c0, 2 raised to the power of 5 minus 0, that is 5, and minus x raised to the power of 0. Anything raised to the power of 0 is 1, and I had said nc0 is equal to 1. So, 5c0 equal to 1 and 2 to the power of 5 is equal to 32. Okay. When r is equal to 2, it is 5c2, 2 to the power of 5 minus 2, which is 3, and negative x raised to the power of 2. Negative x raised to the power of 2 is x square. And what is 5c3? Let us, not 5c3, 5c2. Let us use the calculator to get the, of course it will not be a large number, but let me show you how to get it using the TI Inspire calculator. Okay. So, it is NCR 5, 2, 10. So, it is 10, and this is 2 to the power of 3 is equal to 8. So, 10 times 8 is 80, that is 80x squared. Okay. Next one is having r value as 1. So, r is equal to 1. It is 5c1 times 2 to the power of 4 times negative x to the power of 1. And I had said nc1 is equal to n. Doesn't matter what is the value of n. So, 5c1 is equal to 5. And 2 to the power of 4 is 16. Okay. So, 16 times 5 is how much? Equal to 80. But there is this negative x raised to the power of 1. So, there will be this negative sign in front. It will be negative 80x. Okay. So, we have found the 3 terms from the first binomial expression. Let us move on to the second binomial expression. The second binomial expression is this one. 1 plus 2x raised to the power of 6. And what is the first value of r? It is 2. So r is equal to 2. In CR, so it is 6CR. And mind you, this r and this r, they are not the same. Obviously, over here, r is having a value of 0 and this is having a value of 2. If you think that you will be getting confused by taking the same variable, you can take different variables. But I don't think you really need that because we are getting the terms separately. Okay, just don't mix them up. So r equal to 2 and it is 6CR, so it is 6C2. 1 raised to the power of 6 minus r, 1 raised to anything is 1. So I am leaving that part. And 2 raised to the power of 2. 2 raised to the power of r is 2 raised to the power of 2. And x raised to the power of 2. 6C2. What is that equal to? In CR, 6, 2. 15. So it is 15 and 15 times 4, 2 square is 4. 15 times 4 is 60. So it is 60x square. Then comes r equal to 0. R equal to 0. So it will be 6C0. 1 raised to the power of 6 minus 0, I am leaving that part, and 2x raised to the power of 0. In C0 is equal to 1 and anything raised to the power of 0 is equal to 1. Therefore, this is equal to 1. And what is remaining? R is equal to 1. R is equal to 1. 6C1, 1 raised to the power of 6 minus 1, that is 1, and 2x raised to the power of 1, that is 2 raised to the power of 1 and x raised to the power of 1. In C1 is equal to n. Therefore, 6C1 is equal to 6. 6 times 2 is equal to 12. So, this is equal to 12x. Okay. So, we have found the, let me highlight these terms, otherwise we will be getting confused. We may not be able to locate the terms. So, this one, and this one. Okay. So, now what do? We will be taking, this is the first one and this is the first one. We will be just multiplying these two, and obviously when 32 gets multiplied with 60x square, the term will be having x square, okay, which we need. So, let us do that. We will just be multiplying the terms. So, it is 32 times 60 x square plus, this one is the second middle one, 80x square times 1. So, it is 80x square times 1, and the third one, this one is negative 80x and this is positive 12x. So, negative 80x times 12x. Okay. So, what is this equal to? This is 6 times 2 is 2 and 192. 192x square plus 80x square, and 8 times 12 is 96. So, it is 960, negative 960x square. Okay. Sorry, there should be a 0 over here, right. So, 1920x square plus 80x square minus 960 x square. Okay, let us take the calculator's help. So 1920 plus 80 minus 960 is equal to 1040. Okay. So this is equal to 1040 x square. Okay. And since the question is to give the coefficient, you see, they are asking for the coefficients, not the entire term. This you have to be careful about. If they ask you for the coefficient, you should not give the answer including x square. If they ask for the term only, then you include this x square part. If it is the coefficient, just the coefficient, you cannot include this x square. Okay. So, our answer for this question is equal to 1040. This is the answer. I have made so many boxes, so let me write this to be the answer. Okay. Now let us move on to the next question. So the question says, find the coefficient of x to the power of 4 in the expansion of 2 minus x square raised to the power of 2. Now in this case, we are seeing the term within the binomial expression is also having a square term. Doesn't matter, the method will exactly be the same. It's just slightly more difficult than the previous question, but nothing to worry about. And the second binomial expression is x plus 2 raised to the power of 3. So let's start with an answer. So first of all, we take the first binomial expression or expansion. Okay. So it is 2 minus x square raised to the power of 2. And since x square is the second term, its power will be going on increasing. The power of x square in the first term will be equal to 0. And since this power is 2, there will be a total of 3 terms. 2 plus 1, 3. 3 terms, and the power of the third term, power of x square in the third term will be equal to 2. We know that. So I just write the powers of x square. Okay, just the powers of x square. X square to the power of 2, 0, x square raised to the power of 1, and x square raised to the power of 2. Okay. Now, let us come to the second binomial expansion. It is x plus 2 raised to the power of 3. There will be a total of 4 terms. In this case, x is the first term, so its power will go on decreasing. The first term will be having the power of x as 3, and the last term will be having the power of x as 0. So we just write the powers of x. So it is x to the power of 3, x to the power of 2, x to the power of 1, and x to the power of 0. Now we have to see how do we come to x to the power of 4. This is the first expression and this is the second expression. Okay. So we take the first expression. This is the first, this is the second. If we take this x square raised to the power of 0, this is a constant term. For this term, we will not be having any x. So this constant term, can we multiply this constant term with any of these terms to get to x to the power of 4? Never, because the highest power of x in this expansion is 3. So we cannot take this constant term. Yes, definitely it will get multiplied, but the product, no product will be giving us the power of x as 4. Therefore, we are not interested in this term. Coming to this one, x to the power of 2 raised to the power of 1 is equal to x to the power of 2. So, can this term be multiplied with any of these 4 terms of the second binomial expansion to give us the power of x as 4? Of course, yes, because this is x to the power of 2 and this is x to the power of 2. So, the product term will be having the power of x as 4. Now, what will be, these are the r values. What will be the r value for the first term? Or rather, this is the first term and this is the second term. Let me not do the r value in one step. Let me take the powers of x. So, as I had done in my previous question, I am going exactly that way. I am just using the powers of x. For this, I will be taking the power of x squared. Okay, this you have to be careful about. Do not take this to be the part to be equal to 2. The ultimate power will be equal to 2, but you do not take the ultimate power. You take this one, okay? So, the first expression or expansion's second term, that is the power of x squared is equal to 1. And the second expansion's second term, this is a little tricky because over here you are having the x as the first term. Okay, because this is the second term, this is equal to r. But this is x is the first term. Therefore, the power is 2, no doubt about that. But this is equal to n minus r because x is the first term. That is why I am saying this is slightly more difficult. That is why this is the second question. This is not the first question of this session. Okay? So, since x is the first term over here, therefore, the power of x will be equal to n minus r and not r. What is the value of n? N is equal to 3. So, this is equal to 3. 3 minus r is equal to 2. Okay. So, this is one of the ways that I can or we can come to x to the power of 4. Is there any other way of coming to x to the power of 4? Let us try the remaining term. It is x to the power of 2 whole raised to the power of 2, which gives us the power of x as 4. We are having x to the power of 4. So, we cannot multiply this term with another term containing x. But we can multiply this term with the constant term, which will be a number. So, which one is that term? Obviously, this one. This one is the constant term because it is having the power of x as 0. Clear? So, over here the power is 2. And since x square is the second term, this will be equal to the r value. But over here, the power of x is 0, but x is the first term. So this will be equal to n minus r. And this is what is n in this case? It is 3. 3 minus r. These are the only two possible combinations for which we get the power of x as x to the power of 4. Okay? And 3 minus r is equal to 2 gives us the r value is as 1. And 3 minus r is equal to 0 gives us the r value as 3. Okay? So now that we have found the r values, that is why, since in this case whatever I am writing, that is the r value, therefore I had first of all started to write the r values. Then I thought that no, for the second case it will not be the r value. So, and I could have come to the r value just doing the calculation mentally, but I wanted to show you the calculation. Obviously you are new to this, so I have to show you how to get the r values. Okay, so this is how you get the r values. First thing that you have to remember is, if you are having the x getting raised to some power as one of the terms of the binomial expression, so take that whole thing and raise that whole thing to the power of 0, 1, 2 and so on. Okay, so like over here I have taken x squared. I did not take x, I have taken the whole term x squared. Of course I did not take the sign. I am interested in getting the power of x, so that is why I did not include the sign, but I have included x squared, that this power is included. But when you have to get the corresponding value of r, this is x to the power of 2 whole raised to the power of 1 is equal to x to the power of 2. But do not write 2 over here. Whatever is the power, you have to write this power over here. That will be the value of r. This is the first thing that you have to be careful about. And the second thing that you have to be careful about is, when x is the first term, then the powers of x will be just going on decreasing by 1 every time for every term, and whatever is the power of x, that will be equal to n minus r, not equal to r. Okay? But now we have found the r values for all the terms. We will be just plugging in the r values and getting the terms. So for the first expression, that is 2 minus x squared raised to the power of 2. We will be needing r equal to 1 and r equal to 2. So we start with 2c1, because n is 2. 2c1, 2 raised to the power of 2 minus 1, that is 1. Now I am not writing 2 minus 1. I hope you are being able to understand. In case you are having any difficulty, I would surely be asking you to go through my first video where I had started the binomial expansion terms using the NCR coefficients. These videos are just proceeding sequentially. I am taking topic by topic. So if you just come and try to watch my a video from the middle of the playlist, you may be not it may be possible that you may not understand what am I doing if you are totally new to the chapter. If you are not new, obviously you will be understanding, but in case you are new to the chapter, you may have some difficulty. Okay, so in that case it would be better if you go through the video sequentially. Okay, So since r is equal to 1, it will be NCR in is equal to 2. So 2C1, and first term will be getting raised to the power of n minus r, that is 2 minus 1, which is equal to 1. And the second term will be equal to negative x square. This will be getting raised to the power of 1. So this is 2C1, NC1 is equal to n. So 2C1 is equal to 2, and 2 times 2 is 4. And negative x square raised to the power of 1 is negative x square. So it is negative 4x square. Okay. This is when r is equal to 1. And when r is equal to 2, it is 2C2, 2 raised to the power of 2 minus 2, which is equal to 0, and negative x square raised to the power of 2. And what did I say? What is the value of NCN? It is equal to 1. And 2 raised to the power of 0 is 1, and negative x square raised to the power of 2 is equal to x to the power of 4. This is when r is equal to 2. Okay. So this is all for this expression or expansion, rather 2 minus x square raised to the power of 2. Coming to the second expansion, let me show you what is the second expansion. It is x plus 2 raised to the power of 3. Okay. So the second one is x plus 2 raised to the power of 3. And for that, we are interested in having r equal to 1 and r equal to 3. So it will be 3C1 x to the power of 3 minus 1, which is equal to 2, and 2 to the power of 1. And what is 3C1 equal to? It is 3. 3 times 2 is 6. So it is 6x square. Okay. So this is when r is equal to 1. And the next value that we require is for r equal to 3. So it is 3C3 times x raised to the power of 3 minus 3, which is 0, and 2 raised to the power of 3. So NCN or 3C3 is equal to 1. And x raised to the power of 0 is also equal to 1. 2 raised to the power of 3 is equal to 8. So this is the case of r equal to 3. Now that we have got the 4 terms, we know which one to get multiplied with which one. Negative 4x square should get multiplied with 6x square, and x to the power of 4 should get multiplied with 8. Okay. So let us do that. Minus 4x square should get multiplied with 6x square, plus x to the power of 4 should get multiplied with 8. So this gives us negative 4 times 6 is negative 24 x to the power of 4 plus 8x to the power of 4. Okay. So this is equal to negative 16x to the power of 4. And since they are asking about the coefficient of the term which contains x to the power of 4, this should be our answer. Negative 16. Okay. So students, this brings us to the end of this session. We meet again very soon. Thank you for watching this video till the end. Please like, share, subscribe and comment if you find the video helpful. So bye for now.